Alright guys, we are now looking at target 1.7. And target 1.7 mastery learning objective is I can evaluate formulas to find the volume of prisms and cylinders. So before we can find volume, the first thing we have to think of is area. So again, area is the space inside inside a two-dimensional figure. Okay. The area of a rectangle is area equals length times width. Alright, so hopefully we already know that about a rectangle. The area of a triangle is 1/2, and then I like to use length times width because when we're talking about volume, base has a different meaning. So a lot of times you might have seen it base times height, but volume has bases and has heights. So we're going to do 1/2 length times width. And so if I had like a triangle, the length and the width have to meet at right angles, but kind of like a rectangle too, right? It's just those pieces of it. And then the area of a circle equals pi r squared. R is your radius, right? So if I have a circle, remember your radius goes from the center out. Okay, so that's your radius. If a line goes all the way across, that's your diameter. Okay, so we have to be careful because this formula uses the radius. And then what is volume? Well, just like area is the space inside a two-dimensional figure, volume is the space inside a three-dimensional figure. Sorry, my picture of a triangle got in the way. So the first thing we have is a prism. Okay, and a prism is like a box. You can have rectangular boxes or like a triangular box. Okay. So how we find the volume of a prism is the volume equals, didn't want to write that. The base times the height, okay? If it's rectangular, this base is the length times the width. And then times the height. Ooh, sorry, I might have to erase because I didn't like that H. Okay. So that's for like this example where it's a rectangle. If it's a triangle, then our volume equals 1/2 times length times width. And then times height. Right, it's kind of the difference between, right, so what your different bases are. So looking at our examples, right, this first example has a rectangular base, right? So our volume formula with prisms, it doesn't really matter which one is which. Okay, there's that commutative property of multiplication. it's going to write height again, but it's not height, it's 3. The commutative property of multiplication says I could do 2 times 5 times 3, 3 times 5 times 2, right? I could switch my numbers all around, and I'd still get the same answer. So, as long as you have all 3 of your numbers, you should be good with prisms. So 5 times 2 times 3 is 30. It's in inches, and this is 3-dimensional, so our dimension is cubed, right? Dimension is what you're measuring in. Alright, I'm going to change this problem slightly. This 15 is saying this side, but we don't want that. It makes the problem more difficult, so we're going to call it, we're going to put in what the side is over here, and it's 12. Okay. So we'll just pretend that's a typo of the problem. Don't worry about it. So this is a triangular prism, so we have that triangle. So volume equals 1/2 times length times width times height. Same way, it only matters so much which your length, width, and height are. Then we go 9 and 12. And then 10 is my height. Technically 10 is my height because I can flip figures around. The height connects the 2 bases. So we know this is a triangle. I have a triangle here and a triangle here. This connects the 2 triangles, and that's our height. It's going to be a lot more important when we come to cylinders to see where that height is, even if they're like flipped over. So 1/2 times 9 times 12 times 10 is 540, I believe, feet cubed. And that's it for prisms and cylinder, or for prisms, both rectangular and triangular. Okay? So let's look at the volume of a cylinder. So a cylinder is like a can. Right, that's in the shape of a cylinder. There's 2 circles, and they're connected, right? So again, this connection is where your height has to go. Okay. The volume of a cylinder is the same as the volume of a prism. Volume equals your base times your height. But now, since my base is a circle, that base is pi r squared then times height. So if we look at our examples, find the volume of this cylinder. Okay, so again, volume of the cylinder is pi r squared times height. Again, r stands for radius. It's part of your circle. Hey, look, it's right there. So that's 5 squared. And then my height is what's connecting my 2 circles. Circle, circle, connecting. Right? With these, don't type pi in your calculator. We want to get it as exact as possible. Okay, so since pi would always be rounded, since it continues on forever, we're just going to leave it in terms of pi. So this equals, I'm going to type 5 squared times 18, and I get 450 pi, and this is yards squared. All right, looking at our second example here. Volume equals equals that pi r squared, our base, times our height. Here we have to be very careful. Your radius, again, goes from the center out. This 12 is pointing to the whole way across. Sorry. If the whole way across is 12, then if I'm only going half of the way across, that's 6 centimeters. Okay? So that's 6 squared. And then my height, again, connecting those two. So then we have 6 squared times 3.6. We get 129.6. Bring down that pi, right? And then centimeters cubed. Ooh, I put squared here. That's supposed to be cubed. Sorry. All right, go ahead, turn to the next page. There's a few other examples we want to look at. All right, Cavalari's principle. Cavalari's principle is pretty much the same thing, or it says the same thing as what we just did. Basically the principle, if we look at these shapes down here, it's if it's sideways, it doesn't matter. Okay? So if two shapes have the same base and same height, then they have the same volume. Okay? And again, all it's saying is I should treat these problems where they're skewed like this, and it gives me this 90-degree height, the same as if it was straight up and down. Okay? So here, volume equals length times width times height, which is 2.5 times 4.9 times 2.2. Can't do that in my head. 2.5 times 4.9 times 2. We get 26.95. This is in meters cubed. Same thing here. Volume equals pi r squared times height. Our r, right, is that 6, and our height is that 12. $432. Again, that pi has to come down, and this is also in meters cubed. Alright. So that's Cavalari's principle again. Same thing, still just solving. One of the last things we're going to look at here is solving for a missing dimension if we know the volume. So here it's saying solve for x, and x is our radius, given the volume of the cylinder is 768 pi centimeters cubed. So, this is a cylinder, so I'm going to start with my volume formula. So then, what do we know? Right, now instead of plugging in for R and H, I'm plugging in for my volume, which is 768 pi, right? We don't have to worry about the centimeters cubed, okay? So that was our volume. Now we have our pi. Our r is our x. And h, right, is this 12. Okay, so now instead of plugging in for this and this, I'm plugging in for this and this. Now I'm solving for x. So I'm going to divide by both pi and 12 to cancel both of those out at the same time. And look at that, the pi's cancel here and the pi's cancel here. So then all I have on this side is 768 divided by 12, which is 64 equals x squared. And then I can just take my square root, right? Square roots are the opposite of squaring something. So 8 equals x. Okay? 8 centimeters. All right, we're going to look at this last one. Example 6 will be on an extra video. So a cylindrical cake takes up 32 pi inches. The height of the cake is 4. What is the diameter of the cake? So here's my cake. And the height is 4. So we're going to do this problem the same way. Volume equals pi r squared times height. I know my volume. I don't know my radius. I know my height is 4. Again, I'm going to divide, to get x by itself, I need to divide by both pi and 4. And I'm left with 8. Square root. If I take the square root of 8, being very careful, right? The square root of 8, well, I can break the square root of 8 into 4 times 2. The square root of 4 is 2, right? And I'm still left with this 2. So my radius is 2 square root 2. However, it's asking for the diameter. So I need to go all the way across. So I need to do 2 times 2 square root of 2. And the diameter equals 4 square root 2. So with some of these problems, be careful what it's asking for. Alright, that's it. If you want to go over example 6, there's an extra video going over that. Have a good